Standard 1.4, sketch an angle in standard position in degrees or radians. This is part 2 of 1.4. We're going to focus on radians. Part 1 of 1.4 focused on degrees. Let's take a look at our coordinate plane. And on the coordinate plane, let's place some key angles in radians. So we're starting at 0 pi radians. And a full rotation is 2 pi. But when we divide that into fourths, each fourth is 1 pi over 2. So if we count by pi over 2, so this is 1 pi over 2. Then we have 2 pi over 2, which reduces to just pi. We have 3 pi over 2. And then we have 4 pi over 2, which reduces to 2 pi. And these will help us place angles around our coordinate plane. Let's take a look at our first example. So our first example will be an angle that is 9 pi over 7 radians in size. And we want to figure out where this goes on the coordinate plane. And so in order to do that, we have to figure out where 9/7 pi is in relation to the key angles that we have already indicated on our coordinate plane. One way to do this is to take 9/7 and change it to a mixed number. If we take 9/7 and we change it to a mixed number, we get 1 2/7 pi. How do we get that? Well, ask yourself, how many times does 7 go into 9? That is 1. That's where the whole number is coming from. And how many are left over when 7 goes into 9? That answer is 2. That's where the numerator is coming from. The denominator remains 7. So we have 1 2/7 pi radians. Now we're never going to see it written as a mixed number, but we're going to use this mixed number to help us place the angle. Our initial ray is always on the positive x-axis. And we have to think about where our terminal ray is going to go. Well, 1 2/7 is between 1 pi and 2 pi. Okay? And it's closer to 1 pi than it is to 2 pi. So our terminal ray is gonna go between 1 pi and 2 pi, but closer to 1 pi than 2 pi. So that means it's going to be in quadrant 3. So our terminal ray is going to be somewhere around there. And that's what our angle looks like. Now, another way to think about it is looking at this denominator sevenths. A full circle is 2 pi radians, which is the same thing as 14/7 pi. And so you could potentially divide this full circle into 14 pieces. If we divide it into 14 pieces, you'd have 7 pieces on top. This is not going to work out very evenly, I know, but let's give it a shot. So 1, 2, 3, 4, 5, 6, 7 on top. And we're going to have 7 pieces underneath as well. 1, 2, 3, 4, 5, 6, 7. We are completing 9 of these sevenths. So 9 of these sevenths, 1, 2, 3, 4, 5, 6, 7. That's the one, that's the whole part. And then 2 more sevenths, which is essentially where we had the terminal ray. I'm a little off, but it's right about there. Okay. So you think about dividing this top into sevenths and the bottom half into sevenths and counting 9/7. Or you can think about converting the 9/7 into a mixed number, which is 1 2/7, and then placing where 1 2/7 would be, in this case between 1 and 2. Let's take a look at another example. So let's now sketch an angle that is 5 pi over 8 radians in size. So here's our coordinate plane. And again, we have 0 pi, pi over 2, 1 pi, you don't need the 1 in front, 3 pi over 2, and 2 pi. And 5 pi over 8, 5 pi over 8, let's take a look at this fraction. 5/8 is between the whole numbers of 0 pi and 1 pi. And 5/8 is a little more than a half, so it's slightly closer to 1 pi than it is to 0 pi. Okay. So for sketching, our initial ray goes there on the positive x-axis. We're a little closer to 1 pi than we are to 0 pi. Right? 5/8 is a little more than 1/2. 1/2 pi is up here at the top, so a little bit more is right there. And there's our angle. You can imagine dividing the top into eighths as well if you wanted to. So we divided the top into eighths. Essentially, we want 5 of those eighths. So 1, 2, 3, 4, 5. That's another way to think about sketching it. Let's do an angle that's negative. So for sketching an angle that's negative, let's take, for example, negative 11 pi over 5. For sketching an angle that's negative, same idea as with degrees, we're going to go in the negative direction. So here's 0 pi, and then we're going the negative direction. So negative 1 pi over 2, negative 2 pi over 2, which is negative pi, negative 3 pi over 2, and then this is negative 2 pi. And let's convert negative 11 fifths into a mixed number. How many times does 5 go into 11? The answer is 2. And that gives us 1 remaining. So the remainder is on top. So negative 2 and 1/5 pi. Because this number is greater than 2 pi, we're going to go around more than once. So our initial array is here, and we go around all the way once. That's negative 2 pi. Now we need a fifth of a pi more. So 1/5 is going to be a little bit more than 0. So we're terminating in the first quadrant. If you wanted to, you can imagine the top being divided into fifths. So these green rays are dividing our top half of our coordinate plane into fifths. We've covered negative 2, which is 1 full rotation, and then 1 of the fifths. So here's our negative 2, and then 1 more fifth. And that's what that angle looks like. Let's do one more example. Let's sketch an angle that is 5.3 radians in size. Now notice this number doesn't have a pi attached to it, so we're going to deal with it a little differently. Again, let's think about where our key angles are: 0 pi, 1 pi over 2, pi, 3 pi over 2, and 2 pi. But these angles that we've labeled are all in terms of pi. We could convert these all to decimals. So pi divided by 2, if you did pi divided by 2 on your calculator, you get 1.57. So pi over 2 is approximately 1.57 radians. Pi is approximately 3.14 radians. 3 pi over 2 is approximately 4.71 radians. And 2 pi is approximately 6.28 radians. We want to know where 5.3 is. 5.3 is between 4.7 and 6.28, closer to 6.28. So our terminal ray is going to be in the fourth quadrant. That is how we sketch angles in radians.